Hello everyone, welcome in the session number 4. In this session, you will learn the prerequisite curves for the type 2 examples, and then we will solve some type 2 examples of a double integration. Okay, so prerequisite curves. First 7 curves are like a straight lines only. These are very simple straight lines, but whenever you see that equation, you should able to draw the rough sketch of these curves. So the first curve is x equal to y. So x equal to y, you can remember like this also, that x equal to y is a straight line passing through the origin and it is making an angle 45 degree with x-axis, and this line is exist in first and third quadrant. So this is the line x equal to y. Next, x equal to minus y. X equal to minus y is again a line passing through the origin, but it is in second and fourth quadrant. Third, x is equal to 0 is an equation of a y-axis. So just remember y-axis there. So x equal to 0 is a y-axis that you should remember. So y-axis you should highlight for x equal to 0. Y equal to 0 is a x-axis here. This one is x-axis. X equal to constant. Now, whenever we have to draw the lines like x equal to a, so you can assume some value of a, say a is 1 or 2, and you can draw the x equal to a is a line parallel to y-axis. So this is a line which is a parallel to this y-axis there, x equal to a. Sixth, y equal to constant. Obviously y equal to constant is a parallel to x-axis. Now this is the line y equal to constant. So that about first 6 curves. Next, again a straight line, x plus y equal to 2. Now this is not like a standard straight line here. So x plus y equal to 2. Whenever we have to draw some random straight line, before that you should identify this is the equation of straight line. Why it is a straight line? Because it is a linear equation in x and y. The linear equation in x and y represents the straight line. And to draw this straight line, we just take minimum 2 points of that line. Means we put x equal to 0, we get y equal to 2. We put y equal to 0, we get x equal to 2. So step number 1, we should find out minimum 2 points of the line, and once we get that, we should plot these 2 points here. So if we plot these 2 points, you'll observe 2 comma 0 and 0 comma 2, and after that, yes, we can draw a line passing through these 2 points. So we get the straight line which is x plus y is equal to 2. So this is a way we can draw the straight line. So that about the seventh curve. Next, we require a parabola. Sometimes we have to draw the equation for y square equal to 4x, or sometimes y square equal to x. Remember, whenever the equation have the even power of y, the parabola is symmetric about x-axis. Okay, and when there is a even power of x, it is a symmetry about y-axis. So y square equal to 4x is known as a right-hand parabola. So this is the right-hand parabola. You will observe the curve y square equal to 4x. Similarly, we have x square equal to 4ay. X square equal to 4ay or x square equal to y. Both are the parabolas. Even power of x indicates symmetries about y-axis, and this is upper parabola. Remember, this is one of the most important curve. Many of the examples are on this upper parabola and as well as the previous straight lines only. Okay, so majority of the times you have to draw this upper parabola. So that about a ninth curve. Next curve we require is a circle x square plus y square equal to 4. So this is the standard circle with a center 0, 0, radius 2. So that's one. So x square plus y square equal to 4 circle. Now next one is a ellipse, x square upon a square plus y square upon b square equal to 1. So you can take one of that as a major axis and other as a minor. So I'm taken major axis along x-axis here. So the ellipse have you will observe the length of the major axis is a 6 unit, while the minor axis is a 4 unit there. So that about the ellipse. Now we have an asteroid. This is the new curve for you, asteroid or hypocycloid. So the equation is x raised to 2 by 3 plus y raised to 2 by 3 equal to 2 raised to 2 by 3. Remember, it is similar to the circle only. In the circle, we have a convex arc in each quadrant. So just convert that convex arc to the concave and we'll get asteroid. It is just look like a diamond, but it is not exactly a diamond because there are arc. So these are the, so whatever the convex arc is there, it is a concave arc now. So this is the asteroid. So that is a asteroid. Hardly there may be one example on the asteroid only. Then oblique hyperbola, xy equal to constant. Even though I taken here xy equal to 1, xy equal to any constant, it can be xy equal to 10, xy equal to 20, anything can be there. So this is the oblique hyperbola. Hyperbola occurs pairwise, so there will be two branches. One branch is in the first quadrant. So here is the first branch of xy equal to 1 and the other branch is here. Okay, so that about the oblique hyperbola. And the last curve that we want is the exponential curve y equal to e raised to x. So obviously it is exponentially increasing. So from left to the right, when we move, it will exponentially increase. So this is the e raised to x curve. Okay, obviously this e raised to x intersects to the y-axis at 1, because when we put x equal to 0, y is equal to e raised to 0, that is 1. So 0 comma 1 is a point of intersection with the y-axis. So that about all prerequisite curves that we require for the type 2. Remember, you may come across any of these 14 curves while solving the examples of the type 2. So whenever we get a boundary equations, actually boundary equations in the double integral, our aim is to plot these graph first. We have to draw the rough sketch of these curves and then we have to decide the region of integration. So here is the type 2 when the limits of double integral are not given. So when limits not given, but we are given the boundaries, we are given the boundaries of the region. So say these are the boundaries we are given. So what we have to do it, we have to draw these curves first. So we'll draw the curve, say y equal to f1x. We can draw the curve y equal to f2x. Then we can draw the straight lines x equal to a and x equal to b. Now here is a case one when we take a vertical strip. So the position of the strip is very important to take the limit. So we have to draw just one straight line in the region and you have to look for the lower end. Where the lower end of that strip is touching, the lower end touches to y equal to f1x and the upper end touches to y equal to f2x, and that gives us the limit of y. You will observe that y is varying from f1x to f2x. That becomes the limit of y. Okay, whenever we take a vertical strip, remember the order is a dy dx. Order is a dy dx. And obviously, to get the limit of x, the outer limits are always a constant. When we get variable limit of y, just look for the minimum and maximum value of x over the region. So minimum value of x is a, the maximum value of x is a b. So it is from a to b. So that about our double integral. Double integral is from a to b, f1x to f2x, dy dx is the order. So that is the main part where you should focus here. Most important thing, outer limits of double integral are always constant, always constant. So vertical strip gives us the order dy dx. Okay, now remaining two possibilities you will come across here. Whenever we take a horizontal strip, so the order is always a dx dy for horizontal strip. So you have to see the left end of the strip is touching to the x equal to f1y and the right end touches to x equal to f2y. So that becomes the limit of x, f1y to f2y, and just see the minimum and maximum value of y for the outer limits. So y will vary from c to d there. So that about the horizontal strip. Majority of the questions generally we solve with the vertical strip only. So the case one is mainly the important. So whenever we have a choice, generally we prefer the vertical strip there. Okay, so we always solve majority of the times we are going to solve by the order dy dx. But yes, many of the examples you can solve by any of the order, either dy dx or dx dy. So come to the last case. The last case is a case where the region of integration is either a square or a rectangle. So whenever the region of integration is square or a rectangle, you will observe you can take vertical or horizontal strip, it doesn't matter, or there is no need of strip also. You'll observe y will vary from c to d, x is vary from a to b. The limits are constant. As limits are constant, if you write dx dy as order, so limit of x should be taken inside as a to b, and if you write dy dx, limit of y should be inside as a c to d. So that about case 3. This is only when all the limits are constant. That means the region of integration is a rectangle or the square. Okay. So now we'll see the example, the concept of the strip you will understand in better way with the example here. So come to the first question on the type 2. The example is evaluate the double integral xy dx dy on the region R and this region is in the positive quadrant for x plus y less than or equal to 3. Okay, so first of all, the region is given in terms of inequality. So what we have to do it, so whenever we have to draw the inequality, you may learn this part in the linear programming problem, LPP, how to find out the region of inequality. So we convert that inequality to the equality, means we have to draw the line x plus y equal to 3. So just before we seen in the prerequisite part how to draw the straight line. If you have to draw x plus y equal to 3, if you have to draw the line x plus y is equal to 3, what we'll do it, we'll put x equal to 0, we get y as a 3. We put y equal to 0, we get x as a 3. So indirectly, we have to plot 2 points, say 3 comma 0. Say this is my point 3 comma 0 and this is another point, say 0 comma 3. So we have a straight line. We have a straight line which passes through these 2 points, and the equation of the straight line is x plus y equal to 3. Now this straight line divides the entire xy plane in two parts. One of the part is the non-origin side, this one, and this is the origin side where we have 0 comma 0. So whether origin satisfies this inequality, so x is a 0, y is a 0, 0 is less than 3, yes, it satisfies. So the inequality is towards origin side. So the region is a towards origin, this side. And already it is a given, the region is in a positive quadrant, means it is in the first quadrant. So our region of integration will be this part. This is the region of integration, and already we seen the one of the boundaries x plus y equal to 3. The other boundary is this axis. What is this axis? This x-axis. X-axis is a y equal to 0, and this is a y-axis, that is x equal to 0. So right now our region is bounded by these three curves, and as we discussed, we have to take a strip. We have to take a strip to take the limit. So just draw the vertical strip here. So if we take vertical strip here, so this is my vertical strip, and see the lower end. Where is the lower end touches? Lower end touches to which curve? Y equal to 0, is it? So this, the equation of this curve is y equal to 0, that is x-axis. Where is the upper end touches? Upper end touches to this curve, that is y equal to 3 minus x. So here our double integral becomes I is equal to double integral. Now I am writing the inner limit of y first. The lower end touches to y equal to 0, upper end touches to y equal to 3 minus x, and the outer limit, we have to just see the minimum and maximum value of x over the region. So minimum value of x is a 0, maximum is 3, so it's a 0 to 3. That's one. And here is a xy dy dx. Now dy dx will be our order. So generally we prefer the order dy dx by taking the vertical strip. If you want to solve it with a dx dy, you should draw the horizontal strip. Okay, so now the remaining task is very simple. Just we have to assume x as a constant while integrating with y, and we can continue there. But before that, let I show you small animation so that you will understand how these limits occur, 0 to 3 and 0 to 3 minus x. So our curve is actually y equal to 3 minus x. So I will just change it, 3 minus x. Okay, 3 minus x, and limits are from 0 to 3, because you will observe x is varying from 0 to 3. So the main important thing you will observe, this is a line x equal to 0, this is y equal to 0, and here we have the line x plus y equal to 3. Now if we see the animation here, so there is a small vertical line which is moving. This is vertical line. You will observe the lower end touches to the curve y equal to 0 throughout. Y equal to 0 is the lower limit. Okay, and the upper end touches to this curve, that is y equal to 1 minus x. Not only that, to cover the entire region, we have to drag this strip from x equal to 0. So you will observe now the line is actually will overlap at x equal to 0. This is x equal to 0. Yes, now it is start dragging to x equal to 0. This point P is moving from x equal to 0 to x equal to 3, and that covers our entire region. So 0 to 3 is the outer limit of x, which is minimum to the maximum value of x, and lower end, that is P, is a touching to y equal to 0, upper end say q touches to y equal to 1 minus x. So this is the way we get that limit there. Okay, so that about the limits, and once we got that limit, now we have to integrate it, and to integrate, see the outer limits as it is 0 to 3, x as it is, y square by 2, y square by 2, limits 0 to 3 minus x dx. So this 0 to 3, 0 to 3 as it is, x as it is. So this is the 3 minus x bracket square, 3 minus x bracket square upon 2, and lower limit y replace 0 is a 0 only. So 1 by 2, 1 by 2 is a constant outside the integral. It's a 0 to 3 x. Now I will square the bracket, 9 minus 6x plus x square dx. So here this 1 by 2 is again as it is. Just I will simplify first. Integral 0 to 3, 9x minus 6x square plus x cube dx. Next step I will write on this side. So the integral I becomes this 1 by 2 as it is, and now I'm going to integrate this with respect to x. So it is a 9x square by 2, 9x square by 2. Then minus 6x cube by 3, 6x cube by 3, say x cube, 6 by 3 is a 2, so minus 2x cube only, minus 2x cube, plus x4 by 4, and limits 0 to 3. So the answer will 1 by 2, 3 square is a 9, 9 nines are 81, 81 by 2, 3 cube 27, 27 into 2. Yes, is it 54? 3 cube is 27, it is a 54. And now 3 raised to 4, is it 81 again? And lower limit when you replace x by 0 is a 0. So that about the replacement first. Now we have to simplify this. We have to there are two ways. One of the way you can write down the answer directly. For example, you can take 81 divided by 2. You can write the answer in decimal also, 40.5 plus 81 divided by 4 minus 54, which is 6.75, and divided by 2. So your answer comes 3.375. On calculator, if you write the answer, if you calculate in the decimal, your answer will come 3.375. So this is one of the way. If you don't want this decimal answer, you can write in the fraction, and the fraction answer will be 27 by 8. So by LCM, you can simplify and your answer will come 27 by 8. So choice is your, either you write the answer as a 3.375 or 27 by 8. Okay. So that about the first example on the type 2. We'll move to the next now, example 2. So here is the next question. Here is example 2 where we have to evaluate the same double integral x dx dy, but the region of integration is A, that is a domain, and it is bounded by x-axis. This is the first curve, second x equal to 2a, and the third x square equal to 4ay. So we should draw these three curves first. So first thing, we should draw the curves. Say x equal to, x-axis is there, x-axis is y equal to 0, X equal to 2a, yes, you can draw it anywhere. Say this is x equal to 2a. Now x square equal to 4ay. This is a parabola. So this parabola is upper parabola. So I can draw like this. So this is my parabola here. Okay. So this x square equal to 4ay. Even power of x indicates symmetry is about y-axis. This is upper parabola. X square equal to 4ay. Now the region is bounded by y equal to 0, x equal to 2a, x square equal to 4ay. So the region of integration is this one. And for this region of integration, again we take this vertical strip. If we draw the vertical strip like this, the lower end touches to y equal to 0, the upper end touches to y equal to x square upon 4a. So our integral I will become double integral xy dy dx, limit of y equal to 0 to y equal to x square upon 4a, and the minimum and maximum value of x. See, the minimum value of x is x start with 0 to 2a, 0 to 2a. So exactly similar way we should integrate it now. So 0 to 2a as it is, and the integral of y is a y square by 2, y square by 2. The limit of y is a 0 to x square upon 4a dx. So 0 to 2a as it is, x as it is. We put upper limit, which is a x square, it's a square. So it becomes x4 upon 16a square. This 2 is as it is, 2 into 16a square dx. Lower limit, when we replace y by 0, it's a 0. So indirectly 1 upon 32a square is a constant outside, and this is x raised to 5. The integral is x raised to 6 by 6. X raised to 6 by 6, 0 to 2a, and next it is a 2a raised to 6, 2a raised to 6 upon 32, or 6 into 32a square. So if you simplify this, you will get the answer as, say, a4 by 3 something. Okay, we'll check that. So next step is just you have to simplify. So one of the a square gets cancelled. So you left a4, and then 2 raised to 6 upon 32 into 6, that you have to simplify on the calculator. You will get an answer. Okay, so I will show you the final answer here. So first of all, this is the diagram. Vertical strip PQ is taken, and here a4 by 3 is the answer. The answer is a4 upon 3. So same thing, whatever we done here. Okay, integrated with y first and then integrated with x. A4 by 3 is the answer. So this is the example 2 on the type 2. Third example on the type 2 here. Now the region is bounded by parabola and a straight line. Parabola and the straight line. So we should draw these two curves here first. So y equal to x square and y equal to x. So y equal to x square is again even power of x is there. So upper parabola. So this is y equal to x square. Y equal to x is a straight line here. So this is y equal to x. The region is bounded by these two. So this is our region of integration. Now, generally we are interested to get the point of intersection of the curves. How to get this point of intersection, coordinates of point of intersection? We have to solve these two equations simultaneously. So we have two equations. One is x equal to y. Another is x square equal to y. These two together gives us x square is equal to x. That means x square minus x is a 0. So you can take x common, x into x minus 1 is a 0. So you will observe x is either 0 or 1. When we put x as a 0, you get, see, x equal to y is there. So when x is a 0, we get y as a 0. So we have 0, 0. And when x is 1, y is 1. So 1, 1. So the point of intersections are say 0 0 and 1 1. And now we can take vertical strip. Our vertical strip, this is the vertical strip in the region. This strip, lower end touches to y equal to x square, upper end touches to y equal to x. So our double integral will become, this is the double integral, x square to x square to x, and outer limits of y becomes, sorry, x becomes 0 to 1, minimum value of x and the maximum value of x. So this is a xy, I will multiply inside the bracket, so I get x square y plus xy square dy dx. So that is the double integral we have to evaluate. So that is equal to outer limits 0 to 1 as it is. We are integrating with y. So integration is x square y square by 2 plus x y cube by 3. And the limit of y is x square to x. So we have to replace upper limit minus lower limit. So this is a 0 to 1 as it is. When we put upper limit, so here is x square into x square. So whenever base is the same, there is addition of the indices. So x4 by 2. Here is x cube into x. That is again x4. x4 by 3. Now minus lower limit. See, we're replacing y by x square. X square, it's a square. That is x4. x4 into x square. That is x6. x6 by 2. Here x square raised to 3. So this is 6 plus 1. That is 7. So x raised to 7 by 3 dx. So this is the upper limit. This first we got for upper limit, these two terms, and these two terms for the lower limit. Now the integration with x. So integral of x4 is x5 by 10. This is again x5 by 15 minus x7 by 14 minus x8 by 24, and the limits 0 to 1. So we have to replace now that x by 1. So it is 1 by 10 plus 1 by 15 minus 1 by 14 minus 1 by 24. When we replace lower limit x by 0, it is a 0. No need to replace it. Now another same way what I told you, when the numbers come in a fraction, you can write the answer in the fraction or the decimal. The best way, use a calculator, say 1 by 10, take 1 by 10, which is 0.1, plus 1 divided by 15, it comes 0.16, minus 1 divided by 14, and lastly minus 1 divided by 24. So your answer will come 0.053. 0.053. So this is the way you can write the answer in the decimal. If you're not happy with the decimal, take LCM and write the answer as a 3 by 56 by LCM. So your answer is either 0.053 or 3 by 56. Both are correct. Both are correct. So that about the third question, third example on the type 2 here. Next one, we have to evaluate double integral x square dx dy in the first quadrant, in the positive quadrant, bounded by the hyperbola. This is the oblique hyperbola, then straight line, three straight lines. So all these four curves, we have to draw it, and we have to decide first the region of integration. Okay, so this is a special example where you should understand mainly the limits. Okay, so we are given xy equal to 16. Xy equal to 16 is oblique hyperbola, which look like this. There is another branch in the third quadrant. Actually, no need to draw this branch in the third quadrant, because we are given the region is in the first quadrant only. So that is the reason. Next, we can draw x equal to y. So I'll draw x equal to y here. This is the line x equal to y. The first curve we drawn here is xy equal to 16 we drawn already. Now we have y equal to 0. Y equal to 0 is obviously the x-axis, is it? Y equal to 0 is the x-axis. Lastly, we left x equal to 8. Now this x equal to 8 we can draw before this point, passing through this point, or after that. So we have to check whether this passes through this point. So to solve the two equation, one is x equal to y. Let me solve these two equation. One is x equal to y and the other is xy equal to 16. So that means x square is 16. These two equations simultaneously. So x is a 4. So we got x is a 4. When x is 4, x is equal to y. So y is also 4. So this is point 4 comma 4. Now obviously we have to draw the line x equal to 8. It should go after this point. So I can draw the line x equal to 8 somewhere here. Say my line, this is x equal to 8. This is x equal to 8. Now the last thing, now we have to decide the region. We've drawn all the curves. Many of the students confused with this sector as the required region, but it is not a correct. Why it is not correct region? Because for this sector, this y equal to 0 is not a boundary. We are given a region which have the four boundaries. One is xy equal to 16, y equal to x, y0, x8. So you'll observe the region. Here is a region, this one. For this region, you have all the four possible boundaries: y equal to 0, x equal to y, xy equal to 16, and x equal to 8. So that is the main, or that is the correct region here. Now for this region, yes, we can take vertical strip here. If we take vertical strip, lower end touches to y equal to 0, and here the upper end touches to y equal to x. Upper end touches to y equal to x. Now you will see the minimum value of x. The minimum value of x is 0. It starts with 0. The maximum value of x is 8. The maximum value. So when we drag this strip now, when we drag this strip from x equal to 0 to x equal to 8, the important thing you will observe, the upper end of the strip will vary on the this pink color curve. First y equal to x, but after this point it will move on the oblique hyperbola xy equal to 16. So there is a need to divide the region into the parts. So this is the division here, and the first region we say is a R1, and the second region will say R2. In the region R2 we need one more strip because we have to cover the second region also. So for the second region, the lower end touches to the same curve y equal to 0, but upper end touches to y equal to 16 upon x. 16 upon x. So that is upper end. So this is the way there are hardly 2-3 examples where you require this double strip concept, two strip concept. Why the two strips are required? See, when one strip doesn't move on the same curve, so you'll observe the strip which we drawn in the region R1, it moves on the straight line y equal to x, but after that it start moving on the another curve. Hence there is a need of two strips. So the double integral, whatever the double integral we have, double integral x square dy dx on the region R, on the entire region R, is actually splitted into region R1, the first region R1, which we denoted here, plus the double integral x square dy dx on the region R2. Now we have to write the limits on the region R1. On the region R1, y varies from 0 to x, and you will observe the minimum and maximum value of x over the region R1 is a 0 to this line is a 4. So it is a 0 to 4. So this is the limit on the region R1 plus the double integral on the region R2 now. So on R2, the region R2 start with x equal to 4 to x equal to 8. So outer limits are 4 to 8, while the inner limit y equal to 0, the lower end touches to y equal to 0, upper end 16 by x, and x square dy dx. Now only the thing is left that we have to integrate it one by one. First we integrate with y. So integral of dy will become y, and we'll put upper limit minus lower limit. Okay, that way. So it's a very simple integration. You can easily do that. And I will show you the calculation and the final answer. You'll observe this is the first limit. Here PQ is one strip and P dash Q dash is another strip is taken. This is the region R1, this is the region R2. And when you do the integration, you'll observe the answer will come 448. So integral of dy is taken as y here. And here also integral of dy is y. But the limits are 0 to x here, 0 to x for the inner, 0 to 16 by x is the inner limits of the second integral. So when we put upper limit, so y is replaced by x, so it become x cube. And here it is 16 by x. One of the x get cancelled, only 16x is left. So integral of x cube is x4 by 4. Integral of 16x is a 16x square by 2. And when you use a calculator and simplify, the answer is in integer form 448 only, no fraction. Okay, so you can do the calculation, you can cross check. So that's the fourth example on type 2 that we seen. Two more examples and then we'll stop it. So 448 is the answer. Next question. Our aim is to evaluate the double integral e raised to 2x plus 3y over the triangular region bounded by x equal to 0, y equal to 0, x plus y equal to 1. One of the simplest question again. Here the region is bounded by, say, this is x equal to 0, not x equal to 0. Equation of x-axis is a y equal to 0, is it? So that's a y equal to 0. This is y equal to 0. This is x equal to 0. And we have to draw x plus y equal to 1. So say this is my point 1 comma 0 and this is my point, say, 0 comma 1. So we have a line passing through these 2 points like this. That is x plus y equal to 1. So region is bounded by this 3 straight line. So here is this region. In this region, yes, we have to take a strip. So let me take vertical strip again, as usual. For this vertical strip, the lower end touches to y equal to 0, upper end touches to y equal to 1 minus x, and then integration. So the integral I will become double integral e raised to 2x plus 3y dy dx. Limit of y is a 0 to 1 minus x and outer limits are 0 to 1, minimum to maximum value. Very simple integration. E raised to a, this is a, now we integrate with y, so it is like e raised to a plus by. Integration of e raised to a plus by is e raised to a plus by upon b. So in the same way, e raised to 2x plus 3y, because 2x is like a constant, upon 3, because we are integrating with y. Limits are 0 to 1 minus x dx. Next step, I will write, okay, I will write this side. So we put the limits here with integral 0 to 1. When we put upper limit, when we replace y by 1 minus x, see 1 by 3 is a constant as it is, e raised to 2x. Now we replace here y by 1 minus x, so we get 3 minus 3x. This for upper limit. Lower limit we replace y by 0, so minus e raised to 2x. So indirectly 1 by 3 constant we taken outside the integral 0 to 1. This become e raised to 3 minus x minus e raised to 2x dx. So let me integrate now. So it is a 1 by 3 integral of e raised to minus e raised to 3 minus x is e raised to 3 minus x upon minus 1 minus e raised to 2x upon 2. Limits 0 to 1. We'll replace upper limit now. When we replace upper limit, it is a minus e raised to 3 minus 1, that is 2, minus e square. This is a minus e square by 2. This is for upper limit. Minus lower limit now. This minus minus is a plus and e raised to 3. Lower limit minus sign and this minus is again plus. Anything raised to 0 is 1, 1 by 2. That's 1. So these two terms are for the lower limit, so they have the minus sign. Minus minus become plus. So minus 1 minus half become minus 3 by 2. So the final answer is minus 3 by 2 e square plus e cube plus 1 by 2. So this is the value of the integral. No need to replace the value of e. you can keep this as answer 1 by 3 times minus 3 by 2 e square plus e cube plus 1 by 2. That's one. That's one. The answer, the same answer is here. Okay. So come to the last question then. Last example, example 15. We are going to do it by here vertical strip only. So main thing, you have to draw these 4 straight lines here, x0, x2, y equal to x plus 2 and y equal to x. So to draw these straight lines, we take here, say x equal to 0 is y axis. So this is x equal to 0. X equal to 2, let us take this is x equal to 2. Y equal to x, let I take y equal to x like this, passing through origin. So it is y equal to x. If it is y equal to x and this is x equal to 2, so this point is 2 comma 2. This point is a 2 comma 2. Now lastly we left this line y equal to x plus 2. Already we discussed, whenever we have to draw some random straight line, we put x as a 0. When x is a 0, y we are getting as a 2. When we put y as a 0, x become minus 2. So we can draw the line passing through 0, 2 and minus 2, 0. So 0, 2 is a point parallel to somewhere here. So this is the 0 comma 2. This is the point that we have is 0, 2 and minus 2, 0. Say this is minus 1, minus 2 somewhere here. This is the minus 2, 0. So we'll draw the line which pass through these two, so this way. So this is the line we get. This is the line y equal to x plus 2. Now we have a boundary as x equal to 0, this line. We have a boundary y equal to x, we have this boundary and we have this boundary. So the region is just like a kite here, okay, or diamond, so that type. So this is the region. This is the region of integration. In this region, yes, we are going to take vertical strip again. So lower end touches to y equal to x, y equal to x. Upper end touches to y equal to x plus 2. And so minimum and maximum value of x gives us. So integral will become this is x plus y dy dx. Limits are x to x plus 2, outer limit minimum to the maximum value of x 0 to 2. That's one. So simple integration, yes, you can easily do it. So 0 to 2 as it is, integral of x with y is xy plus y square by 2. Limit of y is x to x plus 2. So the next step 0 to 2 as it is, x into x plus 2 plus x plus 2 bracket square upon 2. This is for upper limit. For lower limit it is a minus x square by 2 dx. So the next step I will write it here. So 0 to 2, when I multiply inside it is x square plus 2x, this term. Now squaring this bracket, x square plus 4x plus 4 minus x square by 2 dx. You will observe this x square will get cancelled with this x square and this x square by 2 gets cancelled with this x square by 2. So we left with the integral as 0 to 2. This is a 2x, this is a 2x. 4x upon 2 is again 2x and 4 by 2 is 2. This much only we left. So indirectly we left with integral 0 to 2 4x plus 2. Now integral of 4x is a 4x square by 2, that is a 2x square, and integral is 2x. Limits are 0 to 2. Put upper limit and lower limit and you can easily prove that the answer is coming 12 there. Okay, so that about the type 2 examples. Just practice. Mainly the most important task, if you observe in all these examples, is the diagram, the rough sketch. Rough sketch is important. because integrands are really simple. Hardly you require integration of x raised to n or e raised to x only. But these diagrams are important where you should draw the vertical strip, you should decide the region and decide the limit. Okay, so that about a type 2. Thank you.